The soils of India are derived from a wide variety of minerals. Thus, they differ physically, chemically and biologically. The distribution does not follow any regular pattern. The soils of India are broadly divided into 5 major groups. Soils with traditional nomenclature and their corresponding orders under soil taxonomy are alluvial soil, that is entisol, inceptisol, alphysol; block soil, vertisol, inceptisol, entisol; red soil, alphysol, inceptisol, altizoil; laterite soil, alphysol, altizoils, oxazole; and desert soil, entisol, eridizole. The other recognized group of soils includes forest and hill soils, saline and alkaline soils, peaty and marshy soils. There can be more than one classification of Indian soils following different criteria. Based on the geographical extent, physical appearance, chemical properties, significance for the purpose of agriculture and the nutritional deficiency, if any, broadly Indian soils can be grouped under 10 groups: alluvial soils, block soils, red soils, laterite soils, forest soils, mountain soils, desert soils, saline and alkaline soils, peaty and marshy soils, tarai soils. Alluvial soils are formed on parent materials transmuted by different agencies, namely water, ice, gravity and wind. Considering the geography of India, which is bounded by the Himalayan mountains, the Arabian Sea, the Bay of Bengal and the Indian Ocean, the two main rivers, the Ganga and the Brahmaputra and its tributaries, it is obvious that the soils are expected to be widely diverse. These soils cover 15 lakh square kilometers from the Sutlej plains in the west to the lower Ganga Brahmaputra valley in the east, and along east and west coasts in the coastal plains. In the North Indian plains, alluvial soils are derived from debris brought by rivers from the Himalayas and the silt left behind the old sea. The coastal alluvium is of tidal origin. The desert alluvium or loess is brought by wind erosion. These soils have a mature profile in flatlands and an immature profile in an undulating surface. Most of the alluvial soils of India have been classified in the orders entisols, inceptisols and alphysols. Geologically, the alluvium is derived into Khadar, the newer or recent alluvium, the Bhangar, the older alluvium. The newer alluvium is sandy and light colored, whereas older alluvium is more clayey, dark colored and contains lime concretions. These soils have a wide range in soil characteristics, namely acidic to alkaline, sandy to clay, normal to saline, sodic to calcareous, shallow to very deep. The alluvial soils are distributed mainly in the northern, northwestern and northeastern parts of India, including the Punjab, Haryana, Delhi, Uttar Pradesh, Bihar, West Bengal, parts of Assam and Orissa. Deltaic alluvial soils are formed from sediments carried by rivers and deposited in the mouths of rivers joining the sea. The deltas of the Ganga, Brahmaputra, Mahanadi, Godavari, Krishna and Kaveri are the most important ones. These soils occur in Orissa, West Bengal, Gujarat, Tamil Nadu and Andhra Pradesh. In Gujarat, the deltaic alluvial soils, which are sandy loam to clay loam, are locally called Goradu soils. These soils vary in texture and composition depending upon the geological formation through which the rivers pass. The Godavari and Krishna rivers pass through basaltic region having block soils, and the deltaic soils are dark and fine textured. The Kaveri delta soils are significantly clayey, although the river Kaveri passes through granitic region having red soils. The Ganga delta soils show high accumulation of organic matter. As in the Sundarbans of West Bengal, due to swampy vegetation. Layers of soil are deposited at varying times and hence the genetic horizons are not common except in very old soils. These soils are fertile and suitable for growing wide variety of crops under different agroclimatic conditions. Soil developed on coastal alluvium are found along the sea coasts of Gujarat, Maharashtra, Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, Orissa, West Bengal and Goa. Their texture and composition are influenced by the nature of parent material of the catchment area. Stretches of coastal sands or sandy soils occur prominently in the coastal area of Tanjavur district of Tamil Nadu, along the Kerala coast, Bapatla in Guntur district of Andhra Pradesh and Puri district of Orissa, where salinity and the water table do not pose problems. The sandy patches are put under plantation of coconut, cashew and casuarina. These are the best agricultural soils because they contain a variety of salts derived from Himalayan and other rocks. They are light and porous, therefore easily tillable. They are good for canal irrigation because of high water table and an easy penetrable stratum. However, these soils are deficient in nitrogen, phosphorus and humus, but not generally in potash and lime. These soils are not suitable for crops requiring water retention around the roots, as the water is allowed to be very deep. Black soils. These soils are characterized by dark grey to black color, high clay content, neutral to slightly alkaline reaction and deep cracks during summer. They are also known as rigor soils and have a characteristically black appearance. Shallow black soils on slopes have been classified in the order Entizols and Inceptizols, while the deep and medium black soils in the order Vertizols. These soils cover 5 lakh square kilometers in Maharashtra, parts of Karnataka, Tamil Nadu, Andhra Pradesh, Madhya Pradesh and Gujarat. At some places, the black soils are also developed on granite and gneiss containing lime and feldspar and are basic in character. These soils occur in areas under the monsoon climate, mostly of semi-arid and subhumid type. Only small pockets occur under arid climate. These soils are very clayey, up to 50% clay content, and therefore are highly retentive of water. This makes them suitable for dryland farming. Because of high clay content, these soils expand when wet and become difficult to flow. During dry season, the black soils shrink and develop big cracks, sometimes up to 1 meter wide. Black soils are good for cotton and sugarcane cultivation. The black soil regions of Maharashtra and Gujarat have contributed tremendously to the growth of cotton textile industry in Bombay-Ahmedabad belt. Black soils are rich in iron, carbonates of magnesium, calcium and in alumina. They are poor in nitrogen, phosphorus, potassium and organic matter. Red soils are derived from weathering of old crystalline and metamorphic rocks under dry conditions and are red due to the presence of iron oxides. These soils are loamy or sandy and have a low cation exchange capacity and a low base status. These soils are characterized by low water retention capacity. These are extensively found in Tamil Nadu, southern Maharashtra, Andhra Pradesh, Karnataka, eastern Madhya Pradesh, south Bihar, western Orissa and in the sedimentaries of northeastern mountains. Most of the red soils have been classified in the order Alphizols. Red soils are deep and fertile in the lowlands and poor and thin in the uplands. In lowlands, red soils are found along with black soils and yield good crops on irrigation. Red soils are poor in nitrogen, phosphorus, potassium and organic matter. Maize, wheat, millets, groundnut and pigeon pea are some of the cultivated crops in the red soil areas. Some portions of red soils are also under forests. Laterite soils. Laterite is a geological term, means literally a rock. The laterites and lateritic soils have been used in the same sense. The lateritic soils are those in which laterization is the dominant soil forming process, that is, elevations of silica and enrichment with oxides of iron and aluminium. Under high rainfall, that is more than 100 centimeter conditions, silica is released and leached downwards, and the upper horizons of the soils become rich in oxides of iron and aluminium. These soils are characterized by a compact vesicular structure in the subsoil horizon composed essentially of a mixture of hydrated oxides of iron and aluminium. This is often referred to as a honeycomb structure. Laterites are well developed on the summits of hills of the Deccan, Karnataka, Madhya Pradesh, the Ghat regions of Orissa, Maharashtra and Kerala, also in West Bengal, Tamil Nadu and Assam. Most of the lateritic soils have been classified in the order altisols and a few order oxysols. Laterites are subdivided into high level and low level laterites. High level laterites are found capping the summits of hills and plateau of the highlands of western and central India. They are not useful for agriculture as these are thin and gravelly. The low level laterites comprising clays and loams occur in the coastal regions on both sides of the peninsula and are of considerable agricultural importance. On the basis of climate, lateritic soils have been grouped into three classes, namely lateritic soils of high rainfall zones with a strongly expressed dry season, high rainfall zones with a weakly expressed dry season, and humid zones with pronounced wet and dry seasons. Although laterization is intensified with increase in rainfall, it is retarded by high rainfall distributed over a long period. The pH of lateritic soils is generally low. The higher the elevation, the more acidic are the soils. The soil clays are kylitic, sometimes with traces of illite. The cation exchange capacity is also very low, that is 2 to 7 centimoles per kilogram. On laterites at lower elevation, rice is grown, and on those at higher elevations, plantation crops such as tea, coffee, cinchona, rubber and cashew grows well under proper soil management. These soils cover areas between 3000 meter and 3100 meter height in the coniferous region. This group of soils occurring in the Himalayas has developed under varying conditions of climate, lithology and topography. The differences in local geological formations and microclimate brought about by the relief and vegetation as well as the types of litter produced under varied plant communities have brought about great changes in their morphology and soil properties. These are dark soils rich in decomposed organic matter but low in pH. Acidic soils have been formed mainly as a result of intense weathering under humid climate and heavy precipitation. The acidic condition occurs under changing condition and vegetation. The decrease in pH with the increase of altitude is the regular trend in the northeast Himalayas forest soils. Soil organic matter increases with increasing altitude. The average value of organic carbon content per 1000 meter rise in elevation in northeastern Himalayan forest soils is about 2.7, 4.0, 5.4 and 6.6%. Total nitrogen content of the soils is also follows the same trend as that of organic carbon. The cation exchange capacity of these soils shows an increasing trend with the rise in elevation. The trend in distribution of exchangeable bases is reversed to that of cation exchange capacity due to higher content of organic matter at high altitude. Mountain soils. These soils are spread over altitudes between 2000 meter to 3000 meter. These soils are shallow, with a grass vegetation occur at high elevation in the Himalayas above the zone of tree growth. Silty loam to loam, well drained, stony, poorly endowed in organic matter and moderately acidic. The carbon nitrogen ratio is wide. Many of these soils have been classified as alphisols. These soils are subject to dislodgement due to landslides and snowfall. Mountain soils are used for forestry and growing potato and subtropical fruits. Desert soils. These soils occur in the hot desertic region extending over approximately 290,000 square kilometer in the northwestern part of India. They form a major part of Rajasthan, southern part of Haryana and Punjab, and northern part of Gujarat. Typical desert soils have been classified in the order aridisols and others in the entisols. The rainfall ranges from 50 centimeter to less than 10 centimeter, the major portion being received during the monsoon. The potential evapotranspiration is 206 centimeter to 162 centimeter, showing net aridity. A major part of the region consists of sand dunes and undulating sandy plains. However, there is a sizable area with a considerable variety of soils resulting from variability of source rock, parent material and history of evolution of the landscape. These soils are covered with a thick brown mantle which inhibits plant growth. Desert soils are derived from adjoining rocks and the coastal region. They are sandy, coarse and alkaline, rich in soluble salts, that is phosphates and nitrates, though actual nitrate content is low. Water is limiting factor for agricultural purposes. Poor in organic matter, they have a varying percentage of lime. Desert soils can be reclaimed through good irrigation. These soils cover arid and semi-arid regions of the northern plains and almost the whole of Maharashtra. The salts from the Himalayas or those derived from the weathering of Deccan rocks get mixed with underground water and during the dry period come up to the surface through capillary action. Saline soils. The soils containing toxic concentrations of soluble salts in the root zone are called saline soils. Electrical conductivity in the saturation extract of such soils is greater than 4 millimos per centimeter at 25 degree centigrade. Exchangeable sodium percentage is less than 15 and the pH is less than 8.5. The soluble salts mainly consist of chlorides and sulfates of sodium, calcium and magnesium. Because of the white encrustation due to salts, the saline soil is also called white alkali. Alkaline soils. These soils are also called non-saline alkali or sodic soils. These soils do not contain any large amount of neutral salts and as such electrical conductivity is less than 4 millimos per centimeter at 25 degree centigrade. The detrimental effect of alkali soil on plants is largely due to toxicity of a high amount of exchangeable sodium and pH. They have an exchangeable sodium percentage of more than 15 and a pH greater than 8.5. Such soils have low infiltration rate and the physical condition is unfavorable. Because of high alkalinity resulting from sodium carbonate, the surface soil is discolored and black and hence called black alkali. Saline alkaline soils. This group of soils is both saline and alkali. They have appreciable amount of soluble salts as indicated by the electrical conductivity values of more than 4 millimos per centimeter at 25 degree centigrade. The exchangeable sodium percentage is greater than 15 and the pH is likely to be less than 8.5. Peaty and marshy soils. Peaty soils occur in humid regions and have an accumulation of high organic matter. Such peaty soils containing considerable amounts of soluble salts occur in parts of Kerala and are locally called Kari soils. During the monsoon, the soils get submerged in water. After the monsoon, the water recedes and rice is cultivated. The soils are black, clayey and highly acidic, that is pH as low as 3.5 and contain 10 to 40% organic matter. The acidity is due to formation of sulfuric acid and decomposition of organic matter under anaerobic condition. Free aluminum and ferrous sulfates are present. The depressions formed by dried rivers and lakes in alluvial and coastal areas give rise to peculiar waterlogged soils called marshy soils. Tarai soils. The word tarai in Hindi means moist, indicating thereby that the tarai soils have a wet regime and high water table conditions for most part of the year. Tarai soils are foothill soils and extend in strips of varying widths at foot of the Himalayas in Jammu and Kashmir, Uttar Pradesh, Bihar and West Bengal. Soils under natural conditions are thickly vegetated and swampy. Several types of grasses and trees form the native vegetation, on removal of which the soils become highly productive. The soils having molic epipedons have been put in the order molizols. The soils are derived from the materials washed down by the erosion of mountains. The parent materials are of alluvial sediments and consist of hard clayey interstratified with beds, bars and lenses of coarse sand and gravel. The tarai soils are of alluvial origin. Relatively high moisture content for the greater part of the year results in luxuriant vegetation dominated by tall grasses. Enrichment in organic matter is of special significance in horizon differentiation and is reflected in greater thickness of a dark colored surface horizon and greater development of dark color in the cambic horizon. Surface recycling of base has resulted in base saturation and neutral to slightly alkaline reaction of the soils. The texture of the surface soil is sandy loam to silty loam and the B horizon shows accumulation of clay. The soils are fertile and with proper drainage become highly productive. The relatively dry soils of tarai are recognized as babar soils. In West Bengal, these soils are brought down by hills, rivers from high mountains and the deposits are mainly sandy, raw humus type and deep black and grey black in color. The soils are acidic, that is pH 4.7 to 5.8, poor in bases and available plant nutrients. They occupy a majority of rice growing area in Jalpaiguri and Coach Bihar. The study on the types of soils in India inferred that there are as many as 10 types of soils exist in India and these types varied greatly in respect of their distribution, formation and properties of soils. Accordingly, these soils can be best exploited or utilized for cultivation or growing of different types of crops or tree species for the betterment of human welfare.